This was a quick Kickstarter lock I had gotten, so I wanted to take a look at sort of a teardown of the lock and maybe some security stuff. So basically, it has an inside-outside handle, and it's not a deadbolt. So I've already opened the box, as you can see. It's just like it just has this whatever you call this thing in it. So there's no deadbolt lock. It's designed to be just the handle part. So all of the electronics are in the outside handle, which is, kind of an interesting choice, let's say. And the idea here is that you have a fingerprint that you can kind of touch the lock and it'll just open. So how it seems like this works is the lock has a little bar that goes through, and so that bar can either rotate, and if it's allowed to rotate freely, when you try to open it, this will stay put, and it won't retract the sort of bolt, whatever you call this, here. So if the lock is authorized, it's going to lock this plate, and as you rotate it, this is going to rotate the outside. So quick notes, I guess, on this guy. There's a little manual, so there's some kind of interesting stuff when you look at it the first time. One thing is that you'll notice there's a little FCC, so if I zoom in on the manual here, it's too far. Zoom in on the manual, you'll notice the FCC ID notice here, but there's no markings at all on this, either side of this thing. So I don't know if there's any sort of FCC stuff or not. Kind of unclear, to be honest. So I was hoping I could use that for teardown photos. I didn't really look further than that. So we don't really care about the rest of it too much. There are these little tags. So basically one of the things you're supposed to be able to do is kind of unlock it with a tag in addition to the fingerprint. We can take a look at what's on those tags. So if I just use my phone to do a read here. So if I put it, oops, no, not that. Put it behind here. You'll see it detects it. I just did it. So basically it's some sort of MyFair Classic, it looks like. So this is an older tag. Has a K of information. In theory, if this is just like a ID, then it's not, it's not too crazy to have just the tag like this. It should be fine as long as you don't kind of end up having an easy attack on it. So this whole thing's driven by an app. So if you go to register, there's a kind of interesting privacy policy, including, for example, where is it in here? Something related to what you agree to, or maybe it's not privacy policy. Oh, there you go. Service agreement. So they have a service agreement here confirming, for example, that you will not damage state honor and benefit, or any spreading rumors disturbing social order, blah blah blah. So clearly there's a bit of a crazy service agreement on this. So I'm not going to bother really using the lock at the app at this point. All right, so let's take a look now at the lock itself. So this is where the batteries go in the handle part. So I'm just going to get rid of the rest of this stuff because basically there's nothing else of interest right now in this. So all we need to do is open the battery compartment. So if we just need some piece of metal to do that. There we go. If I use this lock piece itself, that seems pretty good. So you can see, interestingly, there's some test points behind the battery. So remember, this is the outside handle, right? This is what you're going to hold to open it. So let's chuck some batteries in there first and take a look at what happens. And there's no batteries in the kit. We've got batteries to put in it. Okay, so by default, it's just detecting my finger. And so what you can see is that when it's unlocked, right, this is going to spin roughly freely. So if I were to do this and there was any friction at all on it, it's going to stay still. Like it's going to spin so that the door won't unlock. If I authorize it, now this is going to tightly follow. So it's going to unlock, let me open the door. And then it releases and it's not. So even without the app, there's some basic usage. So we can at least take a look at how that guy's working. All right, so I started to take a look at it. And what you can see is right away, so I've already taken one screw because these screws were really kind of crappy material, and I found they stripped really easily. So when you take this out, this is as far as I got. There's a plate here, and so you can see the interior of the locking mechanism. So we need to take this. It's kind of dirty, so let's see if we can find something to put under it. We can use their nice drill template to help us disassemble it. Okay. So all I've got to do is take that ring off. I happen to have a set of snap ring. There we go. So I don't actually know if this will fully disassemble it or not, but we'll find out. So it's kind of the easiest way I figure to. Okay, that worked. Okay, so this guy comes apart, but it's still stuck. So we got the handle off. At least, so we've got the motor apart a little bit. There's another ring just in here. So right in this guy, in this groove, you can see kind of a ring there. Which, so if I zoom back out, so you see what I'm up to. Try to see if I can peel. There we go. Okay, it's looking better. Just put that on there. There's some sort of stuff crap here that I suspect is covering a hole. Boom. Okay. So there's our NFC antenna. Oops, that popped out of whatever holder's underneath there. Let's dig this out. There we go. Okay. So there's a screw under there. And again, remove this fully. See if that does anything interesting for us. Not really, it's still stuck in there. Oh, okay, yes. Always move stuff slightly more. Okay, so here's the insides of the device. So there's a nice metal plate protecting it, at least, right? That's kind of a good thing. Move my snap ring pliers out of the way. So there's what we got. So yeah, so you can see where the NFC antenna was. This is just, I think, a connection to the case. So it's just giving electrical contact to the case, that little spring pin at F1. The rest of the stuff, so this whole thing here is the motor. You have the fingerprint sensor over here. Right, so that's the fingerprint sensor. I don't know what this is. I haven't really looked in detail, so let's take a look if we can see any part numbers on this stuff. Get an idea for what they were using to do this guy. So just take a look. Okay, and we can actually pull this forward, which is going to make it a lot easier. Just take this whole thing off, experiment a little more. Okay, there we go. So now I've separated the motorized base from just the electronics. And the backside doesn't have a whole lot on it. There's clearly a sort of module that is the fingerprint reader. Let's just pop that out. Bam, okay. Remember roughly how it goes back together. So what's this guy? So if we read the part number of this, these are tiny. iLead. Let's zoom in on that and see if we can help. Oops. Right, so there's the fingerprint reader. So I needed to get the microscope out to see anything. I started to scrape off a bit of the covering on this stuff to get an idea. So all I did was use like a little knife to scrape this stuff off here. And now what we want to do is actually take a look at what parts are used on this thing. So let's do the little fingerprint reader. So if we take a look under this guy here, gotta find that somewhere. Where's that? There it is. And let's zoom that in, or focus, sorry. Okay, bam. So here's the little, there's a little like reader pad thingy. And then the actual chip is right there. Get a bit of an angle on that. So this is, let's Google this here, GSL6101. So it looks like there's some hits here. This guy. So it doesn't look like there's a whole lot on it. So it must appear in a phone as well. So not a whole lot of other details going on there, except it's appearing in a Hawaii phone. Okay, so interesting. Anyway, so not too much on that guy. Let's just keep going. So if we take a look at the main board, what we're going to do is hopefully get an idea what's on that. So I'll put it under a microscope here. And so as I say, I did clean up some of the covering. So where are we? So there's the NFC. Okay, so here's one IC and FM. What's this? If we Google FM. Sorry, everything's upside down for some reason. I'm not doing a good job. 17550E. What we get is a contactless transceiver IC. Hopefully this is not a malicious PDF, but you know, sometimes you just gotta hope. So what's this guy? Okay, so I mean, this thing has an NFC module, so I guess that makes sense. This must be what's doing the that NFC stuff. So what are the final devices over here? let's take a look. This was okay, not upside down finally. So this looks like a N52832. So this has got to be a Nordic semi part. Which one is this? Interestingly, this must be the Bluetooth. So this thing does have Bluetooth. I'm curious they didn't use, maybe it wasn't out yet. There is a Nordic semi device with Bluetooth and NFC. So I kind of expected, expected that to be the case for this, but I guess not. Yeah, sure. Accept your cookies. And what we get is, yeah, there you go. So this is your Bluetooth 5. Yeah, okay, so this does have an NFC A tag. Maybe, I guess this must use a different frequency they wanted in the end or some other reason. But so this is the guy in question here. So Cortex AM4. So I'm going to bet that the test pads on the back here are going to be Jtag. There's two other, let's see here. So here are the test pads on the back, right? We saw those through the enclosure. And there's actually two others off to the side here. So I'm curious what all this stuff is. We'll have to power it up and probe these guys. Now, if these are indeed a programming port, that's pretty suspicious because, okay, so you see ground is this guy. There's a big fat via that's probably VCC, and then there's two little ones that go to via here. And what are these? TP6 and 7. They go to vias on the other side. Let's see, can we follow them? This is kind of super lazy reverse engineering, I'm sorry. I can't really see. Can't see through the crap too well. But if we take a look at these guys, let's see where they go. They go under it. They're basically going up to corner of the IC here. So I don't know. I'll have to take a multimeter to them. Yeah, but if that is, debug, basically what we'll need to check is that the debug port is totally turned off on this. The reason being that, this is accessible from the user's side, right? So what you want to look for is that the debug on this guy is totally inaccessible, because normally what you do is you just program it to disable so you can't read it, so someone couldn't clone it. But in this case, it's riskier because an attacker could easily probe into these. We need to make sure the attacker couldn't then, engage the locking mechanism, because presumably if they can reprogram this micro, they could engage the locking mechanism, right? If this locking mechanism here is just a motor driver, and if you could turn on that motor, however they're doing it, right? I assume there's some sort of magnet that engages or something. If you could turn that on, then you could unlock the door. So I think that'll be the main thing to investigate. But let's take a look what else is on this. So the final thing, what's this part here? 8818, that looks more like a, okay, you know what I bet this is? C3H. I bet you this is an accelerometer or something like that. Let's see, 88 C3H. No hits on that. So let me just put this down so we get a better view of that. Okay. Looks like C3H to me. I don't know. And I assume the top one's just a date code. DC or OCDC 5U9. C3H DC 5U9. Let's check that out. No Google hits on that too. So I'm not totally sure what that guy is. Just Google this as well, QFN. Oh, maybe what's around it is the question. So it's always useful to investigate that. So we have U.B. What's that guy? That looks like a crystal, maybe? Let's get my pointer here. U.B. looks like probably a crystal of some sort. Yeah, okay, there are the two capacitors hanging off the side of the crystal. Oh, there's X1. Okay. Really failing at the hardware hacking here. There's two resistors, like maybe that could be this I2C pull-up. You know, it could be anything. I'm just kind of guessing here. And then decoupling. So, yeah. Something here, some QFN. 4, 5, 1, 2, 3. So this is a QFN 16, it looks like, and it's asymmetric. It's kind of a weird device. And not a lot. Oops, sorry. You can't really see this, can you? Not a lot underneath it. So this is the underside of it up here. So not a whole lot going on there. It's just like power to it or something. On the rest of this guy, there's so this is the board the fingerprint reader was plugged into. There's some stuff underneath it. Let's just pop that open, get a feel for what's going on with the fingerprint reader. Ah, okay, so we have another device. Oh, this is cool. Okay, so what this is, check this out. Let me just pull this apart. It's not under the microscope, so it's a little less eye destroying for you. Okay. Bam. Under the microscope you go. Zoom in on that. Ah, cool. Okay, GD32. So this guy is a ripoff of the STM32, I believe. So you'll notice the ARM logo, but this GD32, what's that? FFPR? Let's Google that. So there's a whole line. There's a line of these devices that are like a clone of the STM32 originally, but then there's extended versions of it. So I get the feeling that this is somehow related to it, which is kind of interesting. Oh, no, okay, so I'm totally wrong here. Let's check this out. So this, I guess this whole module is your fingerprint module, right? So it's got this Giga device. So let's see, it's not fun. Let's go to the Giga device website. But this Giga device is the FFPR. So what is this whole thing doing? So there's a whole bunch of stuff involved in that fingerprint reader, which is fully offloaded, right? So Giga device. Yeah, so what I was thinking of is the GD32. There's like the GD32-100 and some other versions, but I guess they use that prefix for all the ARM stuff. Okay, so it doesn't even show up on their website, but so this might be a specific sort of sold only to certain end customers. So I probably won't learn anything about it, unfortunately, but that's pretty interesting, right? So you have sort of this little module that's doing the actual fingerprint identification stuff, right? And we do have, so if you take a look under the microscope, there are some test points here, which I'm going to assume J2 is used to load firmware if whatever firmware is on the Giga device guy. So I assume that's going to be for firmware loading. And then it just talks over a simple interface to the main micro. So presumably the main micro doesn't need to know a whole lot of anything about the fingerprint stuff because that's all done in this guy here and then this other IC here. And then them working together gives you your fingerprint solution that the main micro just kind of gets like, where'd that main micro go here? Get some sort of pass-fail or something or other. So there's the case. There's the switch over there. And if we put that like that, the question is, does it? Yeah, it definitely tampers. So it's sort of springing off. I don't know. I wonder if it's used at all. I'd be curious. I should try tampering. Yes, that's kind of cool. So it actually has a Tamper Detect in it, which is, hey, you know what? That's a cool feature. I like it. It's good to know, right, that someone's messing with it. Together. Power back up. Initialize, it should. Okay, starts going. So, okay, this. So I actually have the front cover off, so it's probably a little louder. If the tamper, it just kind of beeps. It's hard to communicate the volume. It's not very loud though. It's just this buzzer over here that's doing that. So, oh, and once you take the cover off, it doesn't stop. Of course, the batteries are accessible to the attacker, so they can just take the batteries out. And the weird thing, so, you know, the more I think about this, the more questionable it is about the whole outside handle. Because you'll notice, if you look at this thing, there's no sealing compound in this at all. So it's two metal pieces that fit together with a bit of a ridge. But there's no rubber gasket or anything like that here. And the back side is just like this plastic stuff here. So I suspect if this gets rained on at all, it's not going to be very happy. So you definitely don't want to use this somewhere that you're seeing, like, you know, water going on this thing. So that's a little weird to have an outside handle that seems to not be super water resistant. Yeah, so that's definitely kind of an issue with this whole thing. Okay, so this device that I thought was an accelerometer, I'm pretty sure it is actually. So I thought this because the C3H, I kind of remembered it from some other work I did before. We actually built a board using an accelerometer, and if you search for C3H QFN16, it pops up some hits for the List 3DH, which was the device I was thinking of. And that guy is in LGA 16. So it's not quite QFN because it doesn't have the side things, but the footprint matches. And if these other Google searches are to be trusted, oops, that doesn't work. LGA 16, I think they called it right. Land grid array. Okay, so that's the ST hit. I just can't. I thought the ST data sheet would have the C3H on it. Like normally they have the device marking, but this seems to be all the hits seem to be for that. So I'm gonna bet. Yeah, there you go. This is exactly what ours looks like. It must be. So there must be an accelerometer on this thing. I don't know if it detects like jiggles or stuff like that. Okay. So more lazy reverse engineering here. What I've got up is this is the Nordic device. Keep saying the wrong word here. And here's the data sheet for that device. So what we've got is the bottom right corner is the Jtag pins. So we can see those. So those will be of interest. And maybe the reset pin is of interest too, but the bottom two pins are Jtag. So if we take a look here, we can see those two pins here go to these two vias here. Or wait, no, these two. Sorry, right here and here. And if we see where they're located, I'm just going to flip the board over. There's 4 vias in a horizontal row that will be pretty obvious. And if we go directly up from the last one, that's one of the 2 Jtag pins. So let's flip it over. And what we can see is, there we go. So here we go, right? 4 vias in a row. 1, 2, 3, 4. Bam, up. So these 2 test pads at the corner, These are the ones I had pointed out earlier. They're the Jtag, so not the accessible ones. So these are the user accessible ones. These are the other ones that are kind of hidden. So, yeah, we'll still have to check how it's locked, if it's locked, or if you can just erase it. But that's good, right? Because like if you the issue with these guys is if it's something that we can easily access, you know, that could be not great. So who knows what these are then? Maybe some sort of factory configuration stuff. Hopefully there's some debug info when it's alive. But let's take a look again at this guy in the case. Move some stuff out of the way here. Right, so if I put this guy back in the case, what you can see is the Jtag pins are hidden right here. So they're behind this plastic blob. So if you get through that plastic blob, you might have an attack, or you know, an easy attack on it. Assuming the Jtag's not totally locked, it's kind of rare people totally lock it out to prevent any you know, in-field recovery at all. But you can see it's kind of right there. So that would be, I mean, you know, if this was mounted on a door, it's going to be a little tricky to easily get at that, but not impossible if you had time. Is it harder than just the fact that, you know, this, again, all we're looking at is, this is your, it's not a deadbolt or anything even, right? So there's tools to go around to pop these open. That's probably, at that point, going to be the fastest. I was hoping that if you pop the back off, there's something really quickly you'd push into the pogo pins. That might make an interesting attack. All right, so I went ahead and grabbed a bunch more stuff you can see set up here. So I want to test the last few things. So the Jtag, what the two Jtag pins, and what those other headers are. So what I've got here, so I did a bit off camera to speed it up. I basically just have this is board's being used as a 3.3 volt board. So this is Chip Whisper UFO board, but it's just a convenient source for me of 3.3. So that's powering the device, which should be normally done via batteries. So you can see that here. There's a Jtag connector, which is then running to a Sager J-Link here. And so these two pins, there's two pins that form the SWD pins. That's what would be on the two headers here. I've also got a scope, so we can also then afterwards scope, or before whatever, scope these I/O pads to see if there's any life to them. And before we do that, though, what I would like to do is possibly tape down. So there's this little header, or not header, switch, right? This like sensor here that annoyingly is going to beep, I think, unless I can get it just low enough, but I'm pretty sure. So if I turn on the board, so what I've got now is I can switch the power on and off to this thing. Okay, so maybe it's okay, because if you release it, yeah, you can see it beeps annoyingly, so we'll power cycle it. Okay, so I'll just hold the board down. So I'll test each of these test pads. And I've got a picoscope up here. Let's do that. Bam, there we go. So if I power cycle the board, I don't see any activity on that guy. Don't see any activity, so I just moved the pad over. I don't know if you can really see, but let's power cycle it again. So they're pulled high, so I mean that would to me suggest like I2C or serial or something. Nothing there, so it might be here. Let's activate like a fault mode. No, nothing on that pad. Then I'll move over, activate a fault mode. Okay, nothing like that. So yeah, so I don't know. Those don't seem to be live. If it's programming, it makes sense that it wouldn't be, you know, there's some protocol they're gonna have or something. So that's not super surprising. Let's do the other thing. So I've got these two pins here, and I'm just going to kind of hold them to these pads. I don't know the direction, so it's 50-50 here. Okay. So I'm holding them on. Go back. Oh, I'll turn it on first. Go to the computer and open. I'm now holding it to. Okay, let's open JFlash first, and then I'll hold them again. So this is a Nordic 832. I don't care which one really. Say A. So all we do is hit target connect once I've hold these pins on, power it up. It's going to start beeping soon. Connect. Okay, so there we go. We definitely don't want to do this. So it's saying the device is secured, which I mean is good. They did that. And you have to be really careful with Sega because they really like to unsecure the device. And if you click this button here, it's going to automatically do a mass erase. So we do not want to do a mass erase. I took the volt, I just turned it off. So it'll give some other info about it being secure. So that's just the basically the pins at the side. So there's, if you remember, there's some different headers around. So these pins over here are in fact, you know, as the pinout would suggested, so it's really not a surprise here. These pins are the SWD, and then these are some unknown programming protocol or something like that. There seems to be no serial activity on them for fault, or I tried the fingerprint earlier as well. So that's kind of a quick look at the internals of this particular smart lock. So it was kind of an interesting one. The external PCB and stuff, you know, it's too bad it's not inside. The design's overall pretty good. I mean, because you can see they're at least turning on Jtag lock, which honestly a lot of stuff isn't even doing. There's been a lot of issues with Bluetooth lock, so this is a Bluetooth-based lock in the past. I'm not even looking at anything to do with the Bluetooth protocol or the app. The app had those weird sort of agreements in it that I didn't want to deal with. And you can also see again that the fingerprint sensor is this kind of standalone module, so it looks like all the fingerprint matching logic is happening all in this standalone device. But if I get time in the future, I might, you know, play a game with this thing. For now, that's I think all I'm going to play with right away. So hopefully someone else, if they have time, gets a chance to look at this in more detail. But thanks for watching, and enjoy the rest of the reverse engineering stuff.